Hello friends, Eli Hibbett here with the Pwn Your Homework Physics Series podcast. If you're looking to prepare, review, or gain an added edge or point of view about topics in physics, then look no further. Tune in each week to unlock your understanding of the physical world surrounding us. And now let's dive right in.
Hey, how is everybody feeling today? I am your host, Eli Hibbett, back at you again with another episode of the Pwn Your Homework Physics Series podcast. And today we have for you episode number 80, Physics Brushup Review Volume 1. So, kind of taking last episode to heart, work smarter, not harder. I thought it would be kind of a good idea, since we're in finals time, to give a little, a little status update of where we've been, where we're going, and, take it from there. So, going to be doing a little bit of brush up today, since we're in that time of year. Christmas ever impending, finals coming, midterms coming, tests galore. Don't get stressed out, guys. Don't worry about it. It's all going to happen. It's all going to happen right. So first, let's turn our eyes to the skies. Let's look to the stars and to see. Today we are in the new moon phase, 0% illumination. The full moon is coming in 14 days. And here on glorious Long Island, New York, we got clear blue skies. Should be able to see or not see the new moon up in the sky. So that's what's going on relatively close to us celestially. And I have a quote that I wanted to share with you. Let me see. I hope I don't want to have to paraphrase here. So I was looking back. I was listening to an old episode of the podcast. I remember we used to do inspirational quote of the day, and so I thought we'd bring that back because I was looking for a little bit of information for our review here. And so I wanted to share with you a Carl Sagan quote, and he says, "Every kid starts out a natural-born scientist, and then we beat it out of them. A few trickle through the system with their wonder and enthusiasm for science intact." So what do you think he means by that? Well, I think, most kids have a natural curiosity about the world, which is very inconvenient if you're an adult, because kids like to check out everything and mess it up. And so that's the first round. And then you kind of go through school, which is another round of beating it out of you, because they kind of want you to conform and think about things in a certain way, which in some ways is very helpful. They're teaching you the tools that have worked for our ancestors for generations, but it does stifle original, authentic creativity quite a bit. And then somehow you make it through to college, and there you are, And hopefully you can keep your childlike wonder for science intact. So you are the few, the proud, if you're listening to this podcast, I believe, who have made it through with their enthusiasm intact. So good for us, right? So with that, I thought we would power through. Oh, real quick, little announcement. On Twitter, I'm going to be giving out 101 science tips approved for, first-year physics, Regents Review, great tips. So if you're info snacking and you're on Twitter, check out PWN Physics. And, 101 tips coming out this week during midterm and final time. So do keep an eye out over there for that. But, okay, so let's move forward. So I went through a whole bunch of the old episodes, and I thought that we would just kind of start to summarize everything that we've done so far, and then we'll push beyond even what we've been covering so far on the podcast up to dot and cross product, up through derivatives, and then maybe a little taste of a couple of physical concept reviews, and then talk about where we're going through episode 100. So this will be the first part of that, where we are in volume 1. So I'm going to just give a little recap, a couple of quiz questions for you from each of the topics that I have here, and we'll kind of do that through the volumes. So the first thing I thought we would do is Greek letters, of course, alpha, beta, gamma, delta, epsilon, zeta, eta, theta, and so forth and so on. Critical. Got to know this stuff. Got to know those letters. Got to know when you see them on the test, what do they mean? So I took the first three that occurred to me off the top of my head. What do these stand for? Capital delta, just like a triangle. What does that stand for in physics? Well, capital delta looks like a triangle. It represents the change in a function. So if you have delta v, it's a change in velocity. So your starting or final velocity minus your starting velocity is your change in velocity during a certain time period. Question number 2, theta. What does theta traditionally stand for in physics? You're going to see this one a lot. Theta generally stands for an angle, the angle that you are talking about in a problem. So cosine theta, sine theta is a very nondescript way of referring to an angle. Then you look at the angle of the problem, say, okay, theta in this problem is 30 degrees, so you plug it in and go from there. So theta generally represents an angle in a problem. And sigma, capital sigma, kind of looks like an E. The sigma F equals MA. What does that stand for? Sigma traditionally stands for the summation of a bunch of quantities. So if you have a bunch of forces in a problem, F1, F2, F3, sigma F, add them all together, F1 plus F2 plus F3. So, you got to know what those Greek letters are and what they mean beyond that. But first, get comfortable with the Greek letters. So there we go, Greek letters. Next, units of measure, MKS, all kinds of stuff there. There are 7 fundamental units of measure from which everything else is a derived unit of measure. Like, for example, I don't want to spoil anything here. What can I give you? Yeah, we'll do it at the end. Let's dig into the questions and then I'll finish that up. So what is the fundamental MKS standard unit for mass? The only unit of mass that has a prefix. The kilogram is the standard unit of mass. Also, gram is used quite frequently. What is the MKS standard unit for time? Standard unit of time is the second. What is the MKS standard unit of energy? Standard unit of energy is the joule, which is a derived quantity. MKS standard unit for force. Unit for force is the Newton, which is a derived unit, and here we go. So meter. Kilogram times meter per second squared is equal to 1 Newton. So you multiply all those units together and it gives you this force unit of Newton. So there we go. There's some units of measure. Let's dig into powers of 10, without which we would have lots of decimal points, lots of zeros on all of our numbers. So what is the symbol and what is the prefix for 10 to the minus 3? 10 to the minus 3 is milli with a prefix of a lowercase m. What is the prefix and name for 10 to the minus 6? 10 to the minus 6, we have micro. And since we can't use another m, we use the Greek letter. Back to Greek letters again. Mu for micro. So microgram is mu g. Powers of 10, question number 3. 10 to the third. What do we have? Name and symbol. 10 to the third is kilo, so we use a lowercase k to describe our kilograms, kg. Kilowatts, k, lowercase k, uppercase w. So we gotta be familiar with that stuff. Next step, unit conversion. Guys, let me tell you, if you're in physics, I bet you dollars to donuts you're gonna have a unit conversion question on the final. It'll be something probably crazy where they're like, this alien has this unit of, tesseracts. Convert, and that's a unit of mass. Convert this 25 grams to tesseracts, and they'll give you some unit conversion, and you got to do all kinds of different multiplications to make sure that you're comfortable weaving through all the unit conversions. So here we'll do something a little easy, just since it's a podcast and you don't have your pen and paper out. Maybe you're going for a run, going for a walk. So let's keep it something that you can visualize in your head. So let's convert grams to kilograms. So if you take 1 gram times 1 kilogram divided by 1,000 grams, our grams cancel out and we're left with only the unit of kilograms. Remember, we can cancel our units if we have them in the numerator and the denominator. They're just like numbers. And that gives us 1 gram is equal to 0.001 kilograms. So the quick unit conversion. So what you do is you take your value. You have a unit conversion. You can put it in the numerator and the denominator, but what you want to do is set it up such that the unit that you're converting away from cancels out in the numerator and denominator, and you're left in the numerator with the unit that you would like to eventually convert to. And then you cancel everything out, do the math, and it's done. So there we go, unit conversion. Physical constants, very important. So in our problem, we have variables, we have physical constants, and we have Greek letters, which mean a whole variety of things. But you got to know the difference between them. You got to know which ones are variables, which ones are constants, and which ones are Greek letters, and what they stand for. So physical constant. What does the letter C, lowercase c, represent in terms of physical constants? C represents the speed of light in a vacuum, and it's 2.99 times 10 to the 8th meters per second, or 3 times 10 to the 8th meters per second. A good, one to kind of keep in your back pocket. Lowercase g, what does that physical constant represent usually in physics? G is gravity on Earth, not gravity anywhere else in the universe, but just here on Earth, and it is 9.81 meters per second squared. You should know that one, like the back of your hand. You're going to use it a million zillion times in your calculations, and they'll probably have it on a cheat sheet for you that you can reference a lot of physical constants, but it makes things go a whole lot faster if you can just write it down from memory. And here's one. If you're going to do calculation for gravitational attraction between two bodies, what does uppercase G stand for? Uppercase G is the gravitational constant. This is the constant which describes how two bodies attract with mass anywhere in the universe. It does not matter if you're here on Earth or anywhere. And so that value is 6.674 times 10 to the minus 11th meters cubed per kilogram times second squared. So some wonderful units for you there. So those are 3 physical constants. Lastly, let's do vectors versus scalars. So first off, do you remember what the difference is between a vector and a scalar? A vector has magnitude and direction, whereas a scalar only has magnitude. So if you have, let's get into the examples first, and then we'll go through that in a little more detail. I don't want to spoil anything for you here. So pop quiz: is distance a vector or a scalar? Do you remember? Distance is of course a scalar. Displacement, is displacement a vector or a scalar? Displacement is the vector form of distance. It tells you, So distance, let's say I travel 3 miles. Okay, I travel 3 miles. Where? You don't know. If I travel 3 miles northeast to the store, now you know exactly where that is. So that's a vector. It has magnitude and direction. So let's go to one up from that. Motion. Is velocity a vector or a scalar? Velocity is a vector. Is speed a vector or a scalar? Speed is a scalar. So speed scalar, S's, and velocity vector, V's. Easy way to remember that. So I'm driving on the road at 30 miles an hour. Is my speed scalar? You don't know where I'm going. I'm going down the road. If I was traveling, due south at 30 miles an hour, now you have a velocity vector. You know exactly magnitude, 30 miles an hour, and direction, due south. So there you go. That is, so we have Greek letters, units of measure, powers of 10, unit conversion, physical constants, and vectors versus scalars. All right, I'm tired. Let's take a little breather, and we'll wrap up this episode and come back with volume 2 sooner rather than later, I hope. But all these apps, I have an app which reviews each one of these in detail in a physics Brushup bundle available on the App Store. Just search Eli Hibbett or Elijah Hibbett in the App Store. I'll pop right up, or go over to the blog, pwnyOurhw.blogspot.com. And there's, of course, a link over there. You can click and check it out. If you need that sort of review, by all means, take it. The flashcards, tap review, it's all very useful. So there we go. That's going to be the end of Volume 1, and I should be at you soon with Volume 2. So I hope you enjoyed. Hope you're getting ready for your finals, your midterm tests, and everything like that, and that you're enjoying the wonderful weather in this Christmas season. So I'll catch you next time, guys. But until then, stay frosty and stay in the zone. Catch you next time, guys. Take care.